Characteristic equation and roots of a square matrix. When you have a square matrix, so if A n by n is a square matrix, then matrix A minus lambda I n. So what we are doing, we are subtracting the scalar matrix lambda I n. That is called the characteristic matrix corresponding to A. And the equation determinant of A minus lambda I n equals to 0. This equation is called the characteristic equation of A. Now let us look at the statement of the characteristic root problem. Characteristic root problem essentially is the problem wherein we need to find values for the scalar lambda for which there exists a vector x which should not be equal to 0 satisfying ax equals to lambda x. Ax equals to lambda x. So what we are trying to say that when we multiply a square matrix A with the vector x, that gives us lambda into the vector x. So such a scalar value lambda. That's what we need to find out. Now the values of lambda that solve the equation, they are called the characteristic roots or eigenvalues of this matrix A. Okay. And to solve, what we do to solve the problem, we rewrite the equation. So we rewrite the equation Ax equals to lambda x, and we rewrite, now lambda x is nothing but lambda I and x. Okay. Now this can be written as lambda I minus Ax equals to 0. So what do you have here? Here you have a homogeneous set of equations. You have a homogeneous set of equations out here. So this is a matrix getting multiplied to x equals to 0. So this is a homogeneous set of equations, and for a given lambda, any x which satisfy the previous equation Ax equals to lambda x. This is my equation number 1 and this is my equation number 2. So any lambda that would, for any given lambda, any x that would satisfy that first equation, satisfy 1, will also satisfy 2. Will satisfy 2. That's pretty obvious because we've just rewritten this equation. And this gives us, as I am telling you, this gives us a set of homogeneous equations. Homogeneous equations wherein the equations equal to 0. Okay. So you have n equations in n variables, n equations in n variables, n unknowns. So the set of x's for which the equations is true. Okay, so this set of equation is true is actually called the null space. The null space of A. Okay, it's called the null space of A. Null space in fact or not of A, but in fact of lambda I minus A. Lambda I minus A. Now this equation can have what we are looking for is a non-trivial solution because we are looking for x not equal to 0. Now when will this equation have a non-trivial solution? Non-trivial solution The non-trivial solution will be if and only if matrix lambda I minus A is singular. Okay, it will have a non-trivial solution when the matrix is singular, and this equation is called the characteristic or the determinantal equation of A. This is called the characteristic or the determinantal equation of A. Now we need to see, what I want to prove right now is why this matrix has to be singular. This matrix has to be singular. So let me just take a 2 by 2 case and try to see why. So in the 2 by 2 case, what is Ax equals to 0? Now Ax equals to 0 would be A11, A12, A21, A22 into x1, x2, the vector x equals to 0, 0. So what do I have? I have two equations, two variables. I have A11 x1 plus A12 x2 equals to 0. I have A21 x1 plus A22 x2 equals to 0. Right? So x1 equals to minus A12 upon A11 x2. Let us get this we are getting from first equation, second equation, from 1. Substitute into just normally the way we solve our equation. So I will get minus 2,1 into A12 upon A11 x2 plus A22 x2 equals to 0, and that will give me, taking x2 common, that will give me A22 minus A21 upon A11 into A12. So A12, right? So that is what we will get, that equals to 0. Okay, so this will imply that either x2 equals to 0 or this bracket equals to 0. This bracket essentially is A22 minus A12 into A21 whole upon A11, this equals to 0, which essentially, now x2 cannot be equal to 0. Okay, if x2 is not equal to 0, then A11 A22 minus A12 A21 upon A11 equals to 0. Just carefully notice what is your numerator out here. The numerator is nothing but determinant of A. Determinant of A equals to 0. So this implies that the determinant of A needs to equal to 0, and that is why we are saying that lambda I minus A equals to 0 equation can be solved by getting to know that whether lambda I minus A is singular or not.